All right, so I am Andrew Sutherland. I work at Mozilla on the DOM team, specifically the workers and storage subteam that is dealing with service workers, as well as the workers that do not do what people want right now, and all of the related storage APIs. So I want to go over what our current, the cross-browser storage API story is. There obviously exists Web SQL database, which we will not speak of further. We have number one, cookies. It's a synchronous storage API. It stores only strings, and there's a hard storage cap. The cap is, in fact, so hard that if you try and use too many cookies on your domain, we'll just start evicting them. So you really don't want to be using this for game storage at all, only for network authentication and such. Next, we have local storage, which is a synchronous API as well. And synchronous, no A, also only stores strings, also hard storage cap. 5 megabytes, I think, is pretty much the universal cap. And it has the interesting wrinkle that, at least for legacy purposes in Firefox, it's shared among your entire ETLD +1. That means example.com, if you have foo.example.com and bar.example.com, you're all sharing a 5 megabyte limit, which has caused problems for sites like Wikipedia that tried to cache their JavaScript there, and because Wikipedia shards by language, they ended up sort of running out of quota, so that on some languages you wouldn't have any storage accessible at all. Local storage is also interesting because it is sort of such a nightmare situation for browsers, because if you go to access local storage when your site is loading and we don't already have the data available, we are effectively compelled to block the main thread until we have the data available, which means that we've also optimized it a lot. I would recommend, if you're really concerned about time to interactive, local storage might not be a bad thing to use, but you need to be careful and coordinate with other people on your origin to make sure that you are not storing, I think a very common thing we see is sites will have a auto-appending log. It's fun to gather telemetry and such, but people will just constantly write to local storage with additional, just all of the JSON that they wanted to post to the server. Generates very high I/O writes for the user, and it actually delays your startup next time, because when we go to load your origin, we have to potentially load 4.5 megabytes of data for you when you really only want 100K of it. IndexedDB, which gets a lot of bad press. It is fully promise compatible now across all browsers. That was a problem for a while. It is no longer a problem. You can use promises, and I recommend Jake Archibald's promised IndexedDB wrapper is a good one. It is fully asynchronous. It stores pretty much anything you want because we use the structured serialization API that Postmessage uses. That means object graphs, even if you have cycles in them or something like that, they will go to disk and they will come out of disk. It's also aware of blobs and files with some magic, and I will get to that a little later. IndexedDB uses the quota storage cap, which I'll also get to later as well. Last, we have the cache API, which is technically part of the service workers spec. It is asynchronous, and it's basically a map for fetch request and response objects. Interestingly, it does implement the cache vary header abstraction. So you can put in something that's JSON, and you can put in something that's HTML, and based on what you match for your request, will give you the correct thing based on all of the headers. It does not store posts at this point. If you want to cache your posts for submission later, we do not support doing that yet. There's actually some talk of augmenting IndexedDB to be able to store these request and response objects so that you could do something like that, or if you had a very clever eviction scheme in mind for your cached data. Right now, with the cache API, if you want to perform eviction, you either do something I think Google's Workbox team does, which is they use IndexedDB to actually track how recent something is, or there's a single API right now, Keys, which lets you enumerate the entire contents of your cache, and then you can manually evict things. It's not super efficient, and in some cases, I think in Chrome for a while, if you put too much data in your cache and then you called keys, Chrome would crash, or rather your origin would crash. What's extra probably of interest to people here using WASM, if you're dealing with responses, this is where the browser is able to do things like cache the JS AST caching, like if we've derived something from it, or for WASM, if we've done additional compilation steps, we are able to tie it to the response. At least in Firefox, there's still ongoing optimization work here, but it is like you're making it easier for the browser to help you if you're dealing with response objects. Okay, so I think structured serialization is not free is something we sort of captured earlier today. Like post messaging to a worker, it's not like if you have a complex object graph, you're going to pay for that because we write it to a byte stream, and then when it gets to the worker, we read it back out of the byte stream and create the objects. An issue we've had internally in Mozilla is we actually have had people try and move something that was on the main thread API to a worker, and they were surprised when it still took the exact same amount of time as it did before, because what they were actually doing was doing IndexedDB from the main thread, and by just the cost of using IndexedDB is the same on the worker and the main thread, and it's also pretty much the same cost you're paying when you post message it. And this is sort of something where it's hard for us to improve on this via the spec, especially because we actually need to invoke getters on any objects you might have for side effects. And your getters are allowed to do crazy stuff, like mutate the object that we're serializing as you do it. Please avoid doing that, because we will possibly be able to optimize that more going forward if your object looks like a plain object. Related to this, IndexedDB allows you to create indices on your data, and these indices are based on like traversing your object graph for the same reasons that we need to, it's hard to optimize put and add in the first place for the structured serialization of your actual payload. It's expensive for us to, or it's at least the cost is proportional to how many indices you have and how much of your object's structure we need to traverse. It would be very interesting if there are ways we can help optimize this going forward. But again, it's a little bit hard per spec. But there are things you can do to make post message less expensive and to make IndexedDB storage less expensive. Hopefully everyone is familiar with the fact that on your globals in JavaScript, we have blob and file. File is just a blob with a name attached to it. Blob can be constructed from other blobs, from strings, from array buffer stuff. And basically, it creates an immutable handle on data that is now, because it's a handle, we're dealing with things by reference instead of by value. So if you're post messaging like a 4 megabyte blob from the main thread to the worker, all like the cost for us is just to say this pointer address, and it's a blob. If you were to post message a 4 megabyte array buffer, if you're not transferring it, we have to actually write out all 4 megabytes of payload. So this is a very handy thing to do if you don't need synchronous access to the data. With a blob, you still need to asynchronously get the data via either the file reader API or the fetch API, or some other upcoming APIs. And also, interestingly, in a multi-process world, it's sort of even better because if you're dealing with blobs and they're going between processes, and it's possible they will be sort of further messaged around, we can sort of lazily stream the data when it's actually needed. For example, if you have a service worker and you're responding with a blob, we don't actually consume the blob until the data gets streamed, if it gets streamed. Super sort of interesting is that if you put these into IndexedDB and you get them back out again, at least on Firefox, and I think on sort of all the browsers, it ends up being disk-backed. Like one question I sort of have about like the previous presentation is how much user loss is just due to the browser crashing. Like at some point, you can cause an out-of-memory event for your tab or the browser or just the process you're in, and it'll go away. And that is especially possible on 32-bit platforms. Like on Windows, Firefox has seen this be a serious issue, especially because we have to allocate so much address space to video drivers, or the video drivers need it. So if you put a blob in IndexedDB, pull it out, it's disk-backed, and it's sort of magically reference counted in the sense that that blob is still valid even if you delete the object that's holding the blob from IndexedDB. You can keep using it, and the browser will, assuming no bugs, clean up all the disk usage for you when the time comes. All right, Quota. There's basically two real APIs that expose the realities of how browsers manage Quota for service workers, IndexedDB, and the cache API. The first is navigator.storage.estimate, and it tells you how much you're using, and it tells you how much you're allowed to use before we'll throw exceptions. How much you're using can actually be somewhat of a lie. For privacy reasons, service workers are allowed to request data from third-party sites as no-cores resources that are opaque, and because we don't want to allow sort of side-channel attacks on extracting the actual size of the resources, we will lie about how big the resources are to you. So if you use third-party resources and store them in the cache API, you can actually burn through your quota a little bit faster than you would expect. Here's sort of like the big problem with quota is that browsers don't really know what's the right amount of storage space for your site. So speaking strictly for Firefox, we just sort of guess, okay, well, as the browser, and we're probably the only browser the user uses, we're going to take half of your free disk space and say that that's for quota storage. And we count any existing usage of browser storage as part of that. And then we'll say, okay, your group, which again is ETLD +1, so foo.example.com, bar.example.com, are all limited by the same group storage. We will give you 1/5 of 1/2 of the user's free disk space, up to 2 gigabytes. Just the fact that we're willing to let you use that storage doesn't mean that it's necessarily a good idea, because we have eviction. Right? At some point, Firefox says, oh, I went over my limit for all of the storage for all of the origins, and I should go evict that data. And then we just currently do a least recently used eviction. If you call navigator.storage.persist, we basically exempt you from that. We prompt the user, and then your site is protected, but it still doesn't sort of fix the problem. So buckets are the spec standard for eviction. We'll wipe out all of your site's data if we wipe you out. So the interesting stuff that's sort of going forward spec-wise is we would like to have multiple buckets. We would like you to be able to say, these are different pieces of data. This is the emails the user has composed are something that probably you would want to keep. Gmail would want to keep drafts. But things that are just cached could possibly be evicted. And there's really the big issue of how do we make this something that the user can understand. The background fetch spec is a thing that's being proposed that would let your app say, all right, I'm going to download a 10 megabyte video. It's made up of these individual fetches, and the browser will do that for you without your service worker needing to be active. It also, interestingly, is spec'd to be exposed via the download manager, and this is sort of the best hope I've seen for being able to explain to the user what's happening with storage, is to say, okay, well, this is level 1 of this game. This is level 2 of this game. And it would sort of be my hope that we could also then, if we have these buckets, start with a more reasonable quota. So instead of saying you get 2 gigabytes, but spend it wisely, we could say you get 100 megabytes, and if you want more than that, you're going to need to be able to explain to the user what these hunks of data are, and then we will also be allowed to sort of nuke them based on how recently you've used them. And then I guess I'm out of time, but there is a lot of interesting stuff happening now with third-party origins and iframes, and I'd certainly be interested in discussing that with people, because at least one of the things sort of relative to the previous talk as well is that if you're downloading resources from another site, it's very, as a third-party origin, it's very likely that we will partition that data, and any caching of the WASM or something like that will not actually be cached and reused because privacy reasons. Okay. Yeah, and that's all my slides.